Hello and welcome to our interview with Andrei, medical doctor and lead data annotator at Johnson Labs. I'm Divyanshu Katiyar, a developer advocate at Johnson Labs, and I'm delighted to bring Andrei here today to discuss his recent achievement in publishing a model entirely trained by the team of medical doctors. Now, many of you are aware that data annotation is an important step in developing high-quality AI models, particularly in domain-specific sectors such as healthcare, finance, or legal. The team led by Andre, formed entirely by medical doctors and professionals, worked on annotating medical records and preparing high-quality training datasets that are used for development of healthcare deep learning models. So in this interview, we aim to delve further into the journey that led to this milestone and learn more about the challenges and the victories on the road. So, Andre, before diving into the talk, can you briefly explain the need you are trying to solve here? Can you give in maybe like an example or a use case related to your domain that our viewers can use as a reference or an example, maybe?
Okay, sure. Thank you for the introduction, Dave. So one of the important use cases that we have would be in performing the first steps of a scientific study or a scientific analysis, be either epidemiological or public health related studies. For me, as an orthopedic surgeon, whenever I begin researching any clinical related, let's say, research question, identifying and gathering demographic data of patients is one of the key activities that I must do. This can be either done manually in the old-fashioned manner, or with the help of a model designed to do it automatically for you. The old-fashioned manner is more time-consuming and of course more prone to errors and biases. Yeah.
Okay.
Com-
Wow. That is really useful. So, my next question is, I want to get some clarity here. So your team of medical doctors trained an NER model from end to end in about 4 weeks, right? Without any assistance from the data scientists. Obviously, this is a really great milestone, and I'm excited to learn more about it. But before that, I want to like get some sort of clarity, like because just by saying 4 weeks is very subjective. Well, like with respect to what? So I want to basically get some clarity why 4 weeks time is such a short time to have achieved this, and how long would it have taken you if you did not use NLP Lab for that matter?
Usually in the literature, in the state of the art, the models that are trained take between 3 and 6 months, depending on the team members and the length of the data set. We did it in this short period of time as expected, I say, because the tool that we use, the NLP Lab tool, is very intuitive and very easy to use. And it's one of the advantages that we have with this tool. You can work really fast and get results on models really, really fast. So compared to a classic way of training a model, which, as I said, would take maybe half an year, this was done in 4 weeks. Yeah.
Well, like compared to half a year, 4 weeks is like a really, really short amount of time. That's really impressive. So maybe if you could like start by giving a bit of a background on the project and what inspired your team to take on this challenge.
Yes, me and my team of medical doctors and annotators managed to train, as I said, a medical NER model from scratch in roughly 4 weeks. The team that I had included a professor of physiology and a medical doctor specialized in gastroenterology. As you see, they are non-technical people, and there was no data scientist assigned to us in any step of this project. In terms of inspiration, we were simply trying to ease our day-to-day work in the clinical practice. Let me give you an example. Most of my patient data is in an unstructured format. I use Word files a lot, but I also use PDF documents with different imaging reports. For the sake of example, for a retrospective study, let's say on the effects of a surgical procedure, for instance, without the aid of a model, I need to manually go through all the medical files for the study period, for example, for the previous 5 years, extract information such as age, gender, height, weight, so demographic data, copy them into an Excel file. But this is the case when I have digital data, digital medical files. If not, I have to read through all the printed documents and manually input data in an Excel file, for instance. And it's only then I can continue the analysis on the structured data that I have now in an Excel or other tools. And as you can imagine, this process is very long, is exhaustive, it is prone to error because medical doctors are usually overworked, and as I said, it is prone to multiple biases. For example, I can miss copying data from one place to another. I can miss some relevant informations from the files. I have many typos in the files that I have. And all these issues can be avoided by using the automatic data processing pipelines. Imagine training a DL model to do all of this work for you. And it will make fewer errors. It will process all your documents in a matter of minutes instead of taking it days, weeks, waiting for your colleagues to process everything.
Wow, that is fantastic. I mean, obviously, when you mentioned that, uh, like now you have like the data in electronic, like the health medical records, like you said. If you didn't have that, you would have them on paper, maybe how you would have years ago, a few years ago, maybe. And yeah, I mean, like now that we think about it, it must have been very frustrating to have to have to go through each and every one of those
Exactly.
records. Wow. Okay, yeah, this is really amazing. So my next question is that your team contributed to the training of many healthcare models in the past, but this was done with the aid of data scientists. So how did you do it this time without any assistance from other data scientists or machine learning engineers?
Up until now, my team of annotators just contributed to preparing the training data that we have. Once we had high quality annotations in place by my team, the data scientist came into the picture and started doing training experiments. There were a lot of interactions between data scientists and annotators until we got a model that was good enough to deploy in the production setting. Uh, the switch actually happened when all those exchanges and interactions became possible inside the NLP Lab tool that we have. We can now, as I said, get an overview of how well the team is doing, how qualitative the annotators are. We can experiment with model training with a click of a button and see how good the model is doing. For all the steps that I mentioned in the past, we needed support from data scientists that wrote and executed custom code in almost each case. And right now, that is no longer the case for us with using the tool.
Oh, okay. Well, that is really impressive that your team contributed to training of many healthcare models, and you did not need any assistance from other data scientists. So, what I want to ask here is, are professionals required to have a special training to work with the tool here?
Medical professional, no, actually, no. There is no special training required to work with the tool. We have medical doctors, as I said, they are non-technical, non-IT persons which are used to deal with clinical setting. And our tool, NLP Lab tool, was built for those users who want to annotate their documents and want to access and use pre-annotations generated by AI in the most simplest manner. Our tool is constantly advancing, making it more easier to use for non-technical people. And we have features that make this tool powerful day by day.
Wow. So basically, like you have an NLP lab, you can like just put the data in an NLP lab, you annotate it, you can just pre-annotate it. You basically it's about like a few clicks here and there. Maybe not in the annotation part, but in the training or somewhere or the other. Okay, that is really cool. So uh, obviously, like you mentioned that like the professionals, they did not need any special training. Obviously, they're like non-technical people. They do not need any special training. Uh, so when it came to the model training, like after you are done with the annotation of your data, how challenging did you find the training process using NLP Lab? Did it really help you save a lot of time?
The training process per se is actually quite simple. Let's get started with that. You need to configure the training pipeline, you save your configuration, and you start the training. For me, configuring the pipeline means simply selecting the version of the library that I want to use and the embeddings. I go with all the default values for all technical parameters required to train models usually. And it usually works very well this way. When the training begins, I get access instantly to some overview of the status. And in the end, I see the accuracy metrics. If the results are good and I like them, I publish the model or use it on my own documents, as I gave you the example before, or deploy it in my production environment. Depending on the setup that I choose from my project. Otherwise, I add new training data or I improve the quality of the already annotated files and reiterate. Another thing, very advantageous here is you don't have to export and run your annotated medical files through another third-party software. And this, of course, saves a lot of time. Also, you are not required to wait for someone else in your team to make time to look at your data, look at your results, and come back with feedback.
Wow, so it's like very direct.
Yeah.
Just interact with it. All right. So, like my other question that I wanted to ask is like, how do you basically envision this model being used in medical field? I mean, like, what are some of the potential use cases for it, if you could name some?
This is a demographic model. They are usually used for all types of clinical studies that are designed to analyze patient-related characteristics or patient selection for clinical trials. Concretely, the model detects some entities automatically, as I said, such age, gender, unhealthy habits, affiliations to certain institutions, sexual orientation, that's found in the medical records. Those can afterwards be used for querying the pool of patients or selecting the ones that fit the requirements of the study. That's the use case. It allows me or professionals to analyze my entire pool of patients for a period of 5 years in just a couple minutes. I can afterwards export the data in a CSV format and load it into an Excel file where I can easily apply any filtering or perform my analysis. All that in, as I said, just 10 minutes.
Wow. So maybe I'm guessing, like, with this tool, there would be more people, like, who would want to come up with their use cases and might want to use NLP Lab for it. So, is there any advice you would like to give to other professionals who are interested in developing their own AI models?
Advice. Okay, my advice to anyone trying to analyze text and extract info is to take advantage of this tool. In clinical research, I cannot emphasize the advantages that you have with NLP Lab. Once you try and work with it, it is very hard to go back to the regular way of analyzing data. It proves you that there is a simple way of transferring your knowledge uh, via a model and examples. All you need is to be careful to provide coherent and consistent examples of files and extracted entities. For this, you need to clearly define your taxonomy beforehand. If working with a team, you need to provide concrete examples of how to annotate something and how to not annotate, so positive and negative examples. And you will have to make sure that the team aligns with the guidelines you create. This will lead in the end to creating a more high quality training data. Uh, if you do this puzzle, everything else will fall into place and will be taken care by the tool.
Okay, so you mentioned that the team like should align with the guidelines that is specified by, I don't know, maybe the manager of the project, let's say.
Correct.
So, like when you create a project on an NLP Lab, so I'm assuming like, or maybe like I should ask it straight away, like, do you give your team specific instructions on what to label the hows and all the whys, like why you're labeling something, how do you label something, what are the norms?
So the hows
So,
and whys,
yeah.
yes, we do have those, and the process involves the development of some rules that the medical professional has to follow when they annotate the medical files. These rules are known, as I said, as annotation guidelines, and these guidelines are basically a living document that requires multiple changes throughout the process. And based on the data set and edge cases that the medical doctor finds in those files, the guidelines will be changed. If I recall correctly, for this model that we trained, we had a total of 4 different annotation guidelines that were changed each week.
Oh, so it's like a thorough revision of the guidelines each, maybe
Correct.
weekly, whenever you meet with the team. Okay,
Yeah.
okay, that's very structured. That's very organized. So, according to you, like, what are the advantages for assigning medical doctors to develop AI models over data scientists? Like,
Um, the main advantage is that medical doctors, compared to someone technical, medical doctors already know what are the specific needs in their field, and they
mhm.
can develop the guidelines and that project and the taxonomy into that direction. Uh, as I said, medical professionals are usually aware of what's missing in their domain uh, because they are facing those challenges daily, and they will adjust the model they require in that direction. Whereas a data scientist or IT professionals are not really aware of such needs or the scientific topics that are discussed in the world of medicine.
I see. Yes, that is a very interesting point. Well, the other question that I want to ask is obviously now that you have used NLP Lab, there must be like, you have gained some knowledge about the tool. You have learned something new about the tool. So, like, what are some of the key takeaways that you and your team learned from the project using NLP Lab, and how will you apply these lessons in your future work, let's say?
Um, First of all, gathering any type of clinical data, be it demographic for this model, and not only for research purposes, can be made extremely easy with the use of machine learning trained models. Secondly, you need to have a team, a team minimum of two uh, persons, medical doctors will increase the depth of the extractions and annotations. Uh, the discussions between those two members are actually working as a brainstorming type of conversation, and those discussions between those will in the end lead to better results. So those would be two takeaways, let's say.
I say that makes sense. Obviously, the other users who would uh, be opting to use NLP Lab for their work would definitely look forward to, like, maybe skipping this video towards this part if they don't want to watch the entire interview to know how your experience have been with the NLP Lab. All right. So we are moving towards the end of the interview, but I still have one last question for you. Um, how do you see the role of AI in healthcare evolving with the emergence of annotation tools such as NLP Lab, obviously, over the next few years?
I see a lot of advancement that will be facilitated or helped by uh, improved the models that will improve the medical documentation. And by gaining access to structured information extracted either from unstructured medical records or in general from medical literature, uh, the steps I see are very um, let's say, nourishing for me as a researcher. For instance, personalized medicine aided by AI and machine learning will allow the analysis of genomic data that can lead to a better understanding of some genetic factors behind certain diseases, biomarkers. There are already oncology models published by us. Predictive analysis and analytics, again, helped by AI and machine learning models, will, as we already did, facilitate prediction of certain disease outbreaks or a patient deteriorating really fast. This can be predicted. Uh, I think that medical research in general will drastically improve by automating the unnecessary so far automated the unnecessary manual data analysis that we did by automating it and identifying, for example, new drug candidates, optimizing clinical trial designs, and so on. Yeah.
Well, obviously, I understood most of it, if not all. Obviously, I'm not a medical personnel, so I'm assuming that people who are into medicine, they see it as of, like, a crucial, like, very like utmost importance, uh, what this particular tool can do. And when it comes to understanding that, okay, it can, like, give a better understanding uh, of the entities which are extracted in the medical records, and, like, how they're classified based on the labels. that is just like we can already see like what kind of jump we have made like over the past few years. Thank you so much, Andrei, for taking the time out, and I wish you good luck with further models that you and your team will build.
Thank you. This has been an experience. Thank you for the questions. As I said, this is the first building block that we did. Training a model entirely by medical annotators, medical doctors, and I'm sure that there will be more to come from our team. I invite researchers to use NLP Lab to try it out at least. You will never go back to the classic way of looking at data.